Alrighty, hello everybody and welcome to the wolfSSL live webinar on everything you need to know about medical device security. My name is Kajal Subkota and I will be moderating this webinar. This presentation is being presented by wolfSSL Engineering Manager Chris Conlin. All attendees will be in listen-only mode. If you have any questions, please feel free to use the Q&A box or raise your hand to be unmuted if you'd like to ask the question live, as we will host a Q&A session following the presentation. This webinar will also be recorded and made available on our YouTube channel shortly after the presentation. If you would like to receive a copy of the slide deck as well, please feel free to email us and we will provide that for you. I also invite everyone to follow us on Twitter at wolfSSL, as well as all of our other socials. And again, please feel free to email us at facts, that's FACTS, at wolfSSL.com if you have any additional questions or comments as well. And now I'm going to hand it over to Chris for the presentation.
Thanks, Kajal. Hey everyone, my name is Chris Conlin. I'm an engineering manager here at wolfSSL. Like Kajal mentioned, thanks for joining us today. We'll be looking at how wolfSSL products can help secure medical devices and some of the use cases we've had in that industry. This is our agenda today. We're going to go over a quick introduction to wolfSSL, look at the medical device landscape and some of the attacks that have happened recently, go over the regulatory landscape, some of the security trends that we've seen, the use cases that wolfSSL has seen for as far as medical customers that we have. And then we'll go through a couple of wolfSSL solutions that can be used in medical devices, our SSL TLS library, wolfCrypt FIPS, our secure bootloader called wolfBoot, and wolfSentry, which is our newest product and our embedded IDPS solution. So in general, wolfSSL secures data. That still applies to medical devices, either securing data in transit or data at rest. We have customers in lots of different types of medical devices. Some of those you can see here on this slide. And we'll go through a couple of the use cases in these specific areas and how some of the more technical details related to those products and projects. As a company, wolfSSL has been growing since we were founded. We have over 1,000 or over 2,000 commercial customers today. Our best estimate is we secure somewhere over 2 billion active endpoints at any one time on the internet. And we were founded in Bozeman, Montana. We still have a development office there, but we also have employees and offices spread around different places now as well. We focus on three main areas: securing data at rest with wolfCrypt, securing data in transit. This could be done with SSL and TLS or SSH, most commonly over TCP/IP, but also could be over a number of different transport mediums. We do have some customers just running TLS over straight memory buffers where there's no real transport layer involved at all. And then firmware updates is a third category, kind of mixing together wolfCrypt with a secure transport medium, and also adding in a secure bootloader for secure firmware updates. This slide is a good glimpse, kind of an overview of our current product lineup. You'll see here our wolfSSL library. That's kind of our core product in combination with wolfCrypt for either just crypto only or SSL and TLS on top of that. For wolfCrypt, we have a couple validated and certified versions available for FIPS 140-2. We're currently going through the 140-3 validation process. We have a DO-178C certification for avionics, and also an asynchronous crypto module, which is meant to be used on the server side with cards like Cavium Nitrox and Intel Quick Assist. We have an MQTT implementation called wolfMQTT. That's on the client side. An SSH client and server library called wolfSSH. A TPM 2.0 library called wolfTPM. Our secure bootloader called wolfBoot. Our newest product, wolfSentry, which is an embedded IDPS solution. We do have the author of curl on board as a wolfSSL engineer, and so we offer commercial support packages and consulting for curl. We also have a version of curl that's a pared down version meant for resource constrained devices, which we call tinycurl. And that second row on the bottom here is a set of language wrappers for wolfSSL. wolfSSL is written in C, but we do have users that want to use us from Java, either through the JSSC or JCE providers. or just the straight JNI wrapper. We also have users who want to use this in C#, Python, and JavaScript. So if we move to talking about medical devices, a couple stats we gathered here. As of 2019, there were 15 million medical devices in US hospitals, which works out to an average of 10 to 15 connected devices per patient bed. So that's obviously a lot of devices, and that's just going to keep growing, more of those being connected, and smart elements of those being integrated into the device. If we look at a survey from the Palo Alto Network Unit 42 group that came out in 2020, it kind of gives us a good overall picture of kind of what security looks like right now from their perspective. They found that 51% of threats for healthcare organizations involved imaging devices, and 83% of those medical imaging devices are running unsupported operating systems, just meaning they're older or legacy OSs at this point. Of course, when you get into older software like that, more vulnerabilities are going to be living in the software and in those OSs. 72% of healthcare VLANs or networks mixed IoT and IT assets, which oftentimes can more easily let an attacker in to an IT asset, which should be protected from the medical device network itself. 98% of all IoT device traffic is unencrypted. So obviously there's a lot of room here to layer on security going forward into the future. From the Healthcare Breach Report 2021, medical device attacks had increased by 55% in 2020. And we've seen several vulnerabilities that have affected medical devices come out. A couple of those we put on the slide here are Urgent 11. This was 11 VxWorks specific vulnerabilities in their TCP/IP stack, which were zero-day vulnerabilities that were also found to impact several medical devices. Another vulnerability was the Swaney tooth. This was a Bluetooth SDK stack vulnerability, and so this was also found in medical devices. So just showing us, these vulnerabilities are becoming at least reported more prevalently, and becoming more public as well. Ransomware attacks have also been on the rise. We've seen a couple. The WannaCry ransomware affected some hospitals and medical devices around the world. There's also a 2020 attack on a German hospital that resulted in essentially delayed patient care where the patients needed to be diverted to another hospital. As medical devices have gotten more complex and more connected, there's more layers of software involved and more attack vectors into those devices. When devices were simple and unconnected, there wasn't as much to worry about. But now that everything is networked, data is being sent to the cloud, to hubs, to devices, there's a need to protect patient medical data. With implants comes a whole new kind of set of attack vectors. And also, now that the devices are updatable with firmware updates, we have to protect against malicious firmware updates going into the device. If we look at the regulatory landscape for medical devices, the FDA does have their Digital Health Center of Excellence, which provides some guidance for medical device cybersecurity. One of the drafts that we'll be quoting kind of a couple slides throughout our presentation today is this draft guidance that was fairly recent. It was issued just on April 8th of this year. So FIPS 140-2 and the upcoming FIPS 140-3, this is something that we've heard a lot from our medical customers. It's a best practice for use of the HIPAA security rules. Anything, Department of Defense related or government projects is oftentimes requires to consume a FIPS validated crypto library. FIPS is oftentimes really just a checkbox item, but it can be a deal breaker, which is something that's needed. And then some other terms are kind of floating around, things like designated for FIPS or FIPS ready. These are terms that some customers like to try to use to meet a FIPS requirement. But since it's not actually a full FIPS validation, those typically aren't sufficient. And sometimes those can get flagged if an audit happens as well. If we look into some of the current FDA guidance, which is from that document I mentioned on the previous slide, it does state to select industry standard algorithms and protocols and select appropriate key size, key generation, distribution, management, and protection as well as robust nonce mechanisms. So the takeaway there is, to be using modern industry standard protocols instead of legacy protocols or algorithms that are broken or have been found vulnerable. The second item here is to use current NIST recommended standards for cryptography. For example, FIPS 140-2 or NIST Suite B or equivalent strength cryptographic protection. And so that's where the FIPS would come into the picture as far as the FDA guidance is concerned in this case. So next up, let's look at some use cases that we've seen from wolfSSL customers and some of the security trends as well. The first case here, so these will just be kind of one slide highlighting a specific use case. So this use case is an endoscopic surgery device. The wolfSSL products used in this product are wolfTPM, which is our TPM 2.0 library, and also just wolfCrypt. This was a Xilinx UltraScale Plus device running QNX. The customer is using that TPM 2.0 module for secure key storage. And this customer did have some challenges processing high volumes of streaming data, but using wolfCrypt and having our engineering team help them tune that library correctly, we were able to meet their processing requirements. Second use case here is a dialysis machine. This used wolfCrypt for cryptography, wolfSSH, and also wolfSSL. This is an NXP IMX6 device that was using the CAM hardware crypto acceleration, specifically for AES, XTS, and hashing. This was running on Greenhill's Integrity. And here we had some engineering challenges getting wolfSSL to integrate right down into the CAM device, especially on Integrity. We had to do some custom driver work there, but in the end, we're able to provide a working solution to the customer. And so in this case, when we use hardware crypto, instead of using our wolfCrypt software cryptography, wolfSSL will just call straight down into the hardware crypto, providing both performance increases and code size reductions. And so for a lot of these projects, for example, this is one case where we have the benchmark data up on our wolfSSL.com benchmarking page. So you can take a look and see the performance difference that we recorded in hardware versus software crypto. The next use case here is a portable defibrillator and ventilator. wolfSSL products used were wolfCrypt FIPS, wolfSSL, and also our Python wrapper for wolfSSL. This is on an NXP IMX7 device running Yocto Linux. There were some open source ports used here with wolfSSL. So instead of compiling these against OpenSSL, the customer instead chose to compile them against wolfSSL. And this was done to help meet a FIPS requirement for using validated crypto underneath. And so they were using Nginx, Python's URLlib3, and also Python's WebSocket client. Next use case here is an embedded and connected insulin pump. This used wolfSSL for SSL and TLS. This was on an STM32 device with ThreadX. Here the customer chose us because they wanted a well-supported library that had a small footprint. And we helped them to optimize the footprint to fit down into their target requirements. Next use case here is a connected device hub. This used wolfCrypt FIPS and wolfSSL. This is on an NXP IMX7. Again, another customer that had a FIPS 140-2 requirement. They needed to add authentication to this hub, specifically that used TLS 1.3. And wolfSSL has had TLS 1.3 support now for several years since it was standardized in 2018. This next use case is a migraine helmet, a little bit more unique one. This helmet was designed to help cure migraines. It used wolfCrypt on two different platforms, an NXP M4 running FreeRTOS and an NXP M0 based device running just a bare metal environment with no OS. Here the customer needed to use wolfCrypt to add on additional security on top of their Bluetooth communications. And I believe this is our last use case. This is a tablet that's used during organ transplants. This used wolfCrypt on an NXP IMX8 platform, with, taking advantage of the CAM hardware crypto, again on QNX. Here we focused our engineering effort on AES and ECC performance, helping to optimize some of the throughput there. This also required us to do modifications to wolfSSL to work with the CAM on QNX. The tablet here, in this case, is used to monitor other devices during that organ transplant process. And wolfCrypt is just used to secure data in transit and also data at rest. So over these use cases and some of the other ones that we've also participated in, these are some of the trends that we've kind of seen in regard to security. Securing data in transit, definitely with SSL and TLS, with modern protocols. A lot of customers are looking to move to TLS 1.3 at this point. Securing data at rest with encryption, leveraging secure enclaves, secure key stores, or TPM modules when they're available on the platform, just to add in another layer of security robustness. Leveraging hardware crypto to accelerate performance, and also supporting secure firmware updates and secure boot. This adds in the ability to patch vulnerable software and extend the lifetime of that device. So next up, we'll move on to just kind of covering some of the wolfSSL solutions that can help secure these types of medical devices. The first one of these being wolfSSL, which is our SSL and TLS library. wolfSSL supports up to TLS 1.3 and DTLS 1.2. We've tried to keep the footprint size as small as possible. Typical build sizes range from 20 to 100 kilobytes, depending on build size and compiler and optimization level, of course. Runtime memory is 1 to 36 kilobytes of RAM per session. This footprint size, if you compare that to OpenSSL, is about 20 times smaller. So definitely going to fit much more easily on an IoT or embedded device. We support 30 or 40 operating systems now. That's everything from your standard Windows, Linux, Mac, through a bunch of RTOSes down to just a bare metal environment. We have an OpenSSL compatibility layer, which can be helpful if you're migrating over from OpenSSL to wolfSSL. That implements the top couple thousand OpenSSL functions and just maps them down to wolfSSL internally. We've integrated into a number of different web servers for the server side, Apache, Nginx, Lydie, and also Mongoose. We have hardware crypto support for a bunch of different platforms now and can easily expand that if needed. We have our FIPS 140-2 validation for wolfCrypt. 140-3 is currently in the works. And then we also have done a lot of ports to different open source packages. We've seen this come up in medical devices with things like WPA supplicant, where a customer would want to, add a FIPS validated crypto library into their Wi-Fi authentication. Next up, we'll talk a little bit about FIPS here that can help you meet some of your regulatory requirements. We have, currently one active certificate for wolfCrypt FIPS 140-2. That's certificate 3389. Our 140-3 validation, we have submitted to NIST. And so now we're just waiting on NIST to finish their review process as part of the CMVP. This diagram here just kind of shows you where the wolfCrypt FIPS module fits in relation to wolfSSL and some of the rest of the system. And so we've drawn our FIPS boundary around a subset of wolfCrypt itself, which means the SSL and TLS code is out of validation scope. And so this is done by design because most of the vulnerabilities and bugs that we find in FIPS are in the SSL and TLS layer, not necessarily down in the crypto level. And so a FIPS customer can use the same FIPS validated library from release to release of wolfSSL, still updating the SSL and TLS part of that library without invalidating their certificate. There's a couple of extra code pieces that run when you're using a FIPS validated crypto module. With 140-2, there's these two things run when the library is first loaded. There's a power on integrity check that does an HMAC SHA-256 over the module boundary. There's also a set of known answer tests that run for each algorithm inside the FIPS boundary. These are done kind of by default automatically using a default entry point. So here you can see that we're using the constructor attribute by default for GCC. And then we port this to various compilers and environments as needed. Just a little diagram of how the self-test would run. If the self-test pass, then the application is allowed access into the FIPS module. If they don't, then the module goes into an error state. For doing new validations, there's a couple ways we can do that. We can add a new operating environment to our existing certificate. And an operating environment, or OE, is a combination of the operating system, the processor, the platform, and the wolfCrypt version. We can also do a rebranding validation where we would rebrand our certificate in a customer's name. And then if needed, we can either grow or shrink the module boundary. That's sometimes a little bit more of an involved process, but is needed depending on FIPS requirements. And of course, the time frame for all this is dependent on kind of the scope of the project, the platform, if it's a standard platform or a non-standard platform, and then what we're seeing as far as lab and CMVP times go. Another thing that, like we mentioned, we're seeing as popular with these medical devices, they're doing secure firmware updates. All software contains bugs and vulnerabilities, and so it's good to have a mechanism there where you can update the software to fix vulnerabilities that are found. You can use firmware updates to update and rotate keys and certificates, and both of these have the kind of the side effect of potentially extending the lifetime of your device in the field. And firmware updates are great, but even better is doing secure firmware updates, especially in life critical applications. That the FDA guidance document does have some recommendation around this, at least to the extent that devices should be capable of being updated in a secure and timely manner. And to help out here from our side, we have what we offer as wolfBoot, which is our secure bootloader solution. This is a lightweight, portable, secure boot solution. It's fairly generic. It fits into almost any system, and we've ported it to a lot of different platforms by now. It uses safe code practices, no dynamic memory use. It uses a dual bank update mechanism. So as you can see on the diagram on the bottom, there's a primary partition where your firmware would live, an update partition where your new update would go, and then just a small swap section to use during the update. It's interruptible, which means power fail safe. If the power fails or something happens during the update procedure, it can fall back to the original image. It has protection against downgrade attacks. It also has a rollback mechanism. If the update is done and your application does its own checks and finds out the update isn't valid, it can roll back to the previous image. It's OS agnostic. We've run this just on bare metal as well as a number of RTOSs. No specific hardware is required for it, although we can take advantage of things like hardware assisted bank swaps. And then another product, so our newest product in the last year is wolfSentry. It's our IDPS, intrusion detection and prevention system. And intrusion detection can be interesting to think about for medical devices, just because if we look back to that stat that we saw earlier, that 72% of healthcare VLANs mix IoT and IT assets. In that kind of case, an attacker might be able to more easily get into an IT asset, and being able to monitor a device more actively with a firewall type solution and detect an attack that's happening could be beneficial if you're finding your medical devices in that type of mixture. Benefits to using an IDPS, like I mentioned, you could detect malicious activity based on either static or dynamic rules. You would receive events that malicious activity is happening, and then you could do something with that information. You could do, log at the most simple level, send some kind of alert, or take some kind of other custom action. So to help facilitate this, we wrote wolfSentry, which is our universal kind of dynamic embeddable IDPS. We wanted to bring the desktop and server class type concepts down to the embedded level. So it's at its most minimal kind of a firewall that can either be dynamic or static, depending on the rule set. It has user-defined events with actions, which could include just shutting down the service completely. It has some plugins that ship by default. These could be filters, decision logic, or some kind of orchestration logic of your choosing. We've integrated this nicely with wolfSSL, so there's just an enable wolfSentry build option, and we'll also be rolling that into wolfMQTT and wolfSSH this year as well. And with developing these products is one thing, but we also want to make sure we do as much testing as we can. So we want to maximize the security of our products while also minimizing vulnerabilities, which helps our customers out in the end by having to update less frequently. Of course, we want to try to prevent crashes, which in a medical device situation could be catastrophic. We do a lot of great testing. Every year we're expanding this. We do everything from API unit testing to Cypher suite testing and algorithm testing. We have a bunch of different static analyzers, including Coverity, ScanBuild, and Facebook's Infer. We do memory error detection with Valgrind and fsanitize address, do interop testing against all the other major implementations. Real world builds means we test our customers' build configurations on a nightly basis. We test with a number of different compilers, do peer review essentially on every line of code that makes it into the repositories. Third-party testing, fuzz testing with over 6 different fuzz testers now, and then kind of wrap all this up into a continuous integration cycle with Jenkins. We do pull request testing and then more extended testing on a nightly basis. This is just, we like to kind of visualize our testing as this rainbow of testing, which includes the things I just talked over, as well as a couple additional things. And this is always growing, year by year. This slide gives you kind of a glimpse of our software development process. Everything flows into the source code in the middle. On the left side here, you have specifications that flow down into software design documents, which are used in both API testing, as well as implementation and API documentation. On the right side, you have module and algorithm verification, which is done both by our internal tools, by the NIST testing tools, by our FIPS validations and other certifications. We have our own unit tests, interop tests, integration tests, those things you saw on the previous slide, as well as fuzz testers, memory checks, and static code analyzers, which are on the bottom left. So in summary, why do people use wolfSSL for medical devices? This is a pretty good list of that. They choose us for our expertise and industry experience. We offer commercial support, so we can help you get up and running with integration assistance. We have a wide breadth of platform OS and compiler support, which means, more times than not, we'll just run in your environment that we've already ported there. If not, we can, do a quick kickstart and get us running in your environment as well. We have low memory use and small footprint size, modern protocol support up to TLS 1.3, FIPS validated crypto, hardware crypto support, as well as support for secure elements and TPM 2.0 modules. We do excellent testing. We think we're the best tested crypto and TLS implementation available in the market today. Our full product suite is available, everything from TLS, SSH, MQTT. And then, like we did talk about on the wolfSSL slide, we integrate into a lot of commonly used open source software packages, for example, WPA Supplicant or OpenSSH. So with that, hopefully that was helpful to give you an idea of some of the places we're used in medical devices and how we might help out in future medical devices. We can open it up for questions if you guys have any.
Yeah, we have a couple of questions here. We have one, which is, would you need an IDS if you have Secure Boot?
They're a little bit different from each other. So Secure Boot is, handling your firmware update and you're booting securely, whereas the IDPS is really more, actively watching for malicious attacks, which the bootloader itself wouldn't necessarily be handling it all, at the network level, for example. So they complement each other more than, be a replacement for one or the other.
Awesome. And, as a reminder to everyone, please feel free to use the Q&A box to ask your questions at this time. We have a question here, which is, any target date for the Rust version of wolfSSL?
No target date yet. It's on our 2022 roadmap to have Rust wrappers. We'd like to see it and we're looking forward to it. But oftentimes we, prioritize customer projects first. So we'll see, or we'll hope to get to it sooner than later. That can also always be accelerated if we have a customer that needs that and can fund that. That'll accelerate the timeline as well.
Fantastic. That was the last of our question. If you have any other questions, please feel free to email us at facts@wolfSSL.com and we'll be happy to get back to you. As I've said before, this webinar is recorded and will be made available on our YouTube channel shortly after the presentation. If you'd like to receive a copy of the slide deck, please feel free to email us at facts@wolfSSL.com and we'll be happy to send that over to you. Otherwise, thank you, Chris, so much for the fantastic presentation, and I hope everyone has a great day.